So from this chapter, we're going to look at 2.1 through 2.4, maybe if we have time 2.5, so we can take the test next week. We'll see. But at least these 4 sections have to be completed. Okay, so let's start by defining a function. So let's look at 3 sets of bubbles. They are pairs. And I'm just going to pick whatever. These are 2 sets of numbers. They can be other objects, but let's call it sets of numbers for now. And you can put 3 numbers that you want in each set, it doesn't matter. And I'm going to create the link, the connection. Here is the link. So this number in the first set goes to this number in the second one. This number goes to this set. This number in the second set. This number goes here, from here, here. In the same way, I'm going to create another one like this. And I'm going to create one more like this. So the first set is always set for x. Set of x values. Always the first one. The second one, of course, is the set of y values. Let me know if you cannot see. Let me know if it's not clear. You know the drill, etc., etc. And here is the definition of a function. Function. In short, each x corresponds to only one y value. Anything else is a relation. Anything else, any other type of relationship or connection is a relation, comma, not a function. So now let's go back to the 3 pairs of bubbles. And let's see, would you agree that the first one is a function based on the definition, each x to one y? Would you agree that the first one is a function? Or you will say, no, no, it's not a function, it's a relation.
It's a function.
It's a function, very good. We call it f, or f of x. We don't have to use f, you can use g, we can use t, we can use g, uppercase g, lowercase g, whatever. But we normally like to use f of x. What about the second one? Is the second one a function or a relation?
Relation.
Absolutely. Relation. Because I found one x value that corresponds to 2 y values. So that's why this is a relation. What about the last one? Is the last one a function or a relation?
Relation.
Very good. It's a function. Each x value corresponds to only one y value. Each x value corresponds to one y value. Each x value corresponds to only one y value. It's a function. You notice something very important. These are functions, but they're not the same. I found 2 x values that go to the same y value, which is allowed. It's a function. But this function will not have the property that this one has. We will talk about it later towards the end of chapter 2, about this difference between these 2. Okay, now let's suppose we have graphs. We are given different graphs. Here's a graph. Here's another graph. Here's another one. And I want to graph one more. So we were given the correspondence here between x values and y values, and we established whether it's a function or a relation. Now, based on the same idea, we have to identify, given the graphs, we are asked to identify which one represents a function or a relation. So we look at the first one. Let's look at this one, the third one that I grabbed. What type of function is this?
Linear.
Very good. Well, we know that by the vertical line test, each vertical line will cross the graph in one point. If it's crossing the graph in only one point, then we have this situation. For each x value, there is only one y value. So here's another. For each x value, we have only one y value. Here's another. For each x value, we read only one y value. I'm sorry, I left it off for students. Hello? Yes, it is. Yes, I sent it back to Tiha in the IT. Yes. I'm sorry, but I would love to talk to you, but I'm in the middle of my class. I'm in my Zoom session right now. I'm so sorry. Can you call me? We finish in about roughly an hour. I'm so sorry. I always send the spam emails that I get in at AACC immediately to Tiha. I never open them or attachments, but I always send them to him because he trained me not to open anything, so I never did. But I won't be able to talk to you right now. I'm so sorry. Thank you. I'll talk to you in an hour. Thank you. Bye-bye. Sorry about that. We get spam messages, and I always send them to the IT guy. Tiha is his name. And this gentleman, I think he wanted to tell me not to open it, but I never did. So sorry, my apologies for that. So this is the vertical by the vertical line test. So if we are given the graph, using the vertical line test, we can say, yes, indeed, this is a function. Of course, if I want to test here, and I test with this vertical line test, it makes no sense. I have to test within the x values that for which the graph exists. Here it will make no sense. Here it will make no sense. So I have to test here where the graph is. And I realize that this vertical line crosses the graph in 2 points. So it's this situation. For one x value, I was able to read 2 y values. So that's no good, in the sense that exists. It exists. We will talk about it at the end of this chapter. But it's a relation. So the same thing here. By the vertical line test, every vertical line will cross in 1 point. So this is a function. Of course, this one, we shouldn't even talk about it now. By now, we know what we are talking about. So what is this? Is it a function or not a function?
A relation.
Correct. By the vertical line test, not this vertical line, but through the, I'm going to use the word a little bit later. So this is a relation. So given bubbles, if you want, this is the connection, the link. I call them bubbles for simplicity, but given graphs, we were able to identify functions or not. But here is another possibility. Of course, we can have tables to identify. We can look at that. But here's another situation. Let's say I have 2x minus 3y equals 2. And the question is this a function? I don't know. I do. And we do know. But what we need to do here is solve for y. That's the key. Not a problem. I subtract 2x. I divide by -3. So here we divided by -3. Now I'm asking myself, is this a function? The answer is yes. How come? Because when I make x equals 0, for example, I get y equals -2/3. Just one value. When I make x equals 1, I get y equals 0. Just one value. When I make x equals 3, and so on and so forth. For every x value, I will only find one y value. So each x corresponds to only one y value. That's why this is a function. But now, because we know, we studied a lot of these in the previous chapter, what if I have this? I still have to solve for y. The question is the same. Is this a function? Same question. I solve for y, so I have to add 3. That's my first step. And I divide by 2. But then, what will be my next step? What type of equation is this, since I'm solving for y? And how many solutions will I get? And we reviewed all these in chapter 1.
Well, you'll get 2 solutions.
Indeed, 2 solutions because of y squared, and I have to take the square root. And every time I take the square root, I will never forget to put plus or minus. And I already see that I will have two options. And here is what I see. I see that if I make x equals 0, how many solutions do I get for the simplest one, for x equals 0? Y is plus or minus the square root of 3/2, because this is 0. When x is 0, I get y equals plus or minus the square root of 3/2. Which brings us back to this situation. For x equals 0, if this is 0, I get on the other side the positive square root of 3/2 and the negative square root of 3/2. So such an equation cannot be a function. It must be a relation. Relation. So 2y squared minus 3 equals 4x. Relation. It's sufficient to show that for one x value, we get 2 y values. I don't care about the rest. I don't need to move on to other examples, like I did here. Okay, let's see for 0, let's see for 1, let's see for 3. I'll also show you that it's a function. But here, if I find one x value for which that corresponds to 2 y values, done. It cannot be a function. Now, the other thing that is very important is domain and range. So every time we talk about functions and graphs, etc., 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 we have to find the domain and the range. What is the domain? X values. What is the range? Y values. So back to my first page here, where I use those bubbles. This will be, of course, the domain. This will be the range. Even a relation has domain and range. X values, Y values. A relation exists. This is a relation. It's a circle. Actually, it's two functions, the function from above and the function from below. We'll talk about it later. So all of them have x and y, so domain range, domain range. I would like us to establish and look at some graphs and establish domain and range and answer more questions. I'm going to copy the graph. If you have this page pulled up, page 231, I encourage you to choose any graph from here so we can analyze it. And I'll choose the one that you pick. So if you have the multimedia library up and running, page 231, choose anything, any graph that you would like to work with so we can start, and I'll copy it for everyone who does not have that.